Hello, this is Mr. Henry, and welcome to lesson 2.3, the Pythagorean theorem. So, in this lesson, the essential question says, how do I use the Pythagorean theorem to determine unknown lengths of a right triangle? And before we get too far into the lesson, hopefully you went to seanhenry.org, clicked on Grade 8, Module 2, and did the two activities between the last lesson and this lesson. The first activity was kind of a wrap-up activity dealing with the different transformations, and the next activity was kind of exploring a little bit of the Pythagorean theorem, figuring out what it is a little bit, trying to get a basic idea of it, and it's kind of something that you could do in a classroom either. So kind of here's just the page for the introductory activity for this Pythagorean theorem activity, where it has you doing something with, you could do it with graph paper, or you could go through the steps it has here on the website, and I'm not going to go through them right now, but it kind of helps you understand a little bit about what the Pythagorean theorem says and does. So the warm-up says, what do you know about the Pythagorean theorem? You might have maybe just made a list, some things you might know. You might know it only relates to right triangles. It's not every single triangle, it's just the right triangles. You might know that the essential question says it's used to find unknown lengths of sides, so maybe you know you can use it to find missing side lengths of a right triangle. Maybe you know that it's named after an ancient Greek named Pythagoras. There's all kinds of little tidbits of information you might know. You might even know the formula, which we'll get through here in a second. So, first off, right triangle. A right triangle is a triangle with a 90-degree angle, meaning that it has one right angle. You can't have a triangle with more than one right angle, so it's a triangle that has a 90-degree angle, a right angle. Okay, the Pythagorean theorem is this formula: a squared plus b squared equals c squared, where a and b are the legs of the triangle, and c is the hypotenuse. So legs, you probably get, they're kind of like they help hold it up, but you may not understand the hypotenuse. Well, lucky you. The next vocab word is hypotenuse. So that hypotenuse is the longest side of the right triangle. And it's pretty easy to find. First off, if you can't tell what's the longest side of the triangle, it's always the one diagonally across from the right angle. So there's this little property of triangles you may not know, but if you would have any triangle, and this works for even triangles that aren't right triangles, across from the smallest angle is the smallest side. Across from the biggest angle is the biggest side. And that's always going to be true for triangles. So in this case, this 90-degree angle is the biggest angle of this triangle. So across from it is the biggest side. So that's what the hypotenuse is. It's just the longest side of the right triangle. And when we're talking about our Pythagorean theorem, it's always going to be the c value. The a and the b can be the two different legs. It doesn't matter which way you put them, but the hypotenuse always has to be the c. So, first problem here says we're going to find the length of the missing side of the triangle. And the figures may not be drawn to scale. So here I have a triangle. It says this side is 12, this side is 5, and I want to find this missing side. In this case, I'm looking for the hypotenuse. So let's see. Well, first thing, if you're ever given a formula to do something, write down the formula. A squared plus b squared equals c squared. And since this is my right angle, that is the hypotenuse. So this side is going to be my letter c. And since I don't know what it is, I'm going to leave it c. But my a and b are just these other two sides. So it doesn't really matter which way you put it. You can put 5 squared plus 12 squared, or 12 squared plus 5 squared. You're going to get the same answer. So now we solve. So So 5 squared is 25. 12 squared is 144. Add that together. Let's see, that gives you 169. This number might ring a bell from last chapter when we were talking about square roots. 169 is actually a perfect square, which is good because the way that I need to get this c by itself, the way we learn to solve this equation is if we square root each side, the square root and the c squared cancel. So we have c equals, and that is 13. So the length of that side is 13 feet. Letter B. Same process. So first thing I do is I write down the formula. A squared plus B squared equals C squared. And I'm looking for the hypotenuse. I'm looking for the C, this longest side, so I leave it a variable. The other two, doesn't make a difference how you put them. You can put 4 squared plus 3 squared or 3 squared plus 4 squared. Let's see, 3 squared is 9. 4 squared is 16. 9 plus 16 is 25. And look at that. If we square root each side to get rid of the c squared, c equals 5. So the length of this side is 5 centimeters. So this Pythagorean theorem is very useful. It's actually something we're going to be spending quite a bit of time on in class. But here's one I'd like you to try. So I have a triangle with sides length of 7, 24, and hypotenuse of c. Go ahead and see if you can find out how long that missing side is. Pause the video. When you're ready to continue, hit play. Okay, so let's see. Formula a squared plus b squared equals c squared. I'm looking for the hypotenuse, so I leave the variable a variable. The other ones, just 7 squared and 24 squared. 7 squared I know is 49. 24 squared I have no clue. So let's see. 24 times by 24 equals 576. Alright. So I'm going to add these together. 576 plus 49 equals 625. I remember that one. If I take the square root of each side, which is what I'm going to do, because it's what we need to do to get this variable by itself, I'm going to get c equals 25. So the length here is 25 yards from this point to that point. That is the distance. Example 2. Here we're going to find the length of the missing side of the triangle again, but what you're going to notice here is now the missing side is not going to be the hypotenuse. It's going to be one of the other sides. So we're going to solve this using the same method. So I'm still going to take my formula, a squared plus b squared equals c squared. This is my hypotenuse. In this case, that 10 is going to go in for c. That's where this problem is going to be slightly different. The hypotenuse is always the letter c. These other two sides are going to be the a and the b, and it makes no difference which way you do it. I'll leave the a the same, and the b is going to be my 6. That's not a 6. It's going to be 6 squared. And we do a bit of solving. That gives me a squared plus 36 equals 100. Subtract 36 on both sides. We're getting the variable by itself, right? A squared equals 100 minus 36 is 64. And I know if I square root both sides here, I get a equals 8. So the missing side here is 8 miles. So I can use the Pythagorean theorem in other ways. I don't have to always just find the hypotenuse. I can also find one of the other sides of a right triangle. And in fact, it can be used to find any side of a right triangle if you know the other two. Letter B. Same dealio. A squared plus B squared equals C squared. That is a formula that you should stick inside your brain somewhere so you can remember it. It's going to happen a lot. My hypotenuse here is 17. So I put 17 squared. This side is my 15 squared. And that missing piece is still going to stay A squared for my variable. Or I guess if you wanted to, you could always throw in the letter from the problem. So you could make it not a B. Make it a D squared. You can do that. 15 squared. I think that's 5. I think it's 250. 225. 225 is what I think. Squared. There we go. 225 equals. I have no clue about 17 squared. 17 squared. 289. And then we want to get the variable by itself. So we have to get rid of this adding piece. So I'm going to subtract 225 from each side. These cancel. D squared equals, it's going to be small. It's probably in the 30s or something. Clear. 289 minus 225 equals 64. I was off. And then finally square root each side like we did before, and D equals 8. So just like the last problem, this missing side is 8, in this case, kilometers. So you can examine the problems if you need to, see the work I did, except I just changed the page on you. Examine the problems if you need to. Not too shabby. Just following the same steps, solving equations, getting the variable by itself, getting rid of the add and subtract. Finally, when the variable is by itself, you can square root each side. Here's one for you to try. This is letter C. Go ahead and try the problem on your own. When you're ready to continue, hit play, and we'll go through it together. Okay, let's see how we did. Formula first. A squared plus B squared equals C squared. That is my hypotenuse, so 26 squared goes here. The two other legs can go in the A and the B anywhere you want them. I am going to put my K here and my 10 here. Now, simplify both sides. So 10 squared is 100. 26 squared, I have no clue. 26 squared, 676. Solve the variable, so I need to get the variable by itself. Subtract 100 to both sides. K squared equals 576. Finally, square root each side, and I get K equals minus 100 square root 24. So my missing side here is 24 inches long. If you could, please go ahead and answer this question. It says, how do you use the Pythagorean theorem to find the missing side of a right triangle? Take a minute or so, pause the video, come up with a good answer. When you're ready to continue, hit play, and we'll go through it together. So, how do you use the Pythagorean theorem to find the missing side of a right triangle? Well, you write down the formula, you plug the pieces into the formula where they belong, making sure the hypotenuse, the longest side, goes in for the C. Then you solve the equation. You get the variable, you simplify both sides, you get the variable by itself. When you have the variable by itself, you square root each side, and then you'd get something like A equals 12 or C equals 36. And that's the length of the missing side. most of the problems you're going to see in terms of Pythagorean theorem are not going to be just straight up giving you a triangle and going, what's the missing side? Most of the time, they're going to be wordy problems. And that's where we're going to spend a large amount of our time when we're talking about Pythagorean theorem is on the word problems. So here we go. The first one says, a right triangle has side lengths of 8 feet and 12 feet. How long is the hypotenuse? All right. Picture. Draw a picture. You need a right triangle. We need to know how long is the hypotenuse, which means we don't know how big that side is. That's our x. That's our missing piece. But the other two sides are 8 feet and 12 feet. Notice how ugly my picture is. Makes no difference if you can draw or not. All that matters is you can understand the thing you drew. So, Pythagorean theorem this thing. A squared plus b squared equals c squared. My missing side is my x, so I can throw the x in there. And the two legs go for the a and the b. 8 squared plus 12 squared equals x squared. Can't do anything with this yet. Over here, though, I can simplify. 8 squared is 64. 12 squared is 144. Simplify some more. 64 plus 144 is making me think it's going to be 208. 64 plus 144 equals 208. So I've simplified both sides as much as possible. The only thing left to do is square root each side. That cancels out the x squared, so I have x equals, and the square root of 208 is 14.4. If you're not sure if you're right, just check it again. 208 square root, still 14.4. And it is okay to get decimal answers. Not every single problem are you going to get a perfect whole number. By the way, the perfect whole numbers we have been getting are called Pythagorean triples because those three numbers together make a perfect right triangle every time. But not every right triangle will have those. You are expected as students to be able to know some of the most common ones. For example, 5, 12, 13. 5, 12, 13. That is Pythagorean triple. That's one of the most common. Also the 3, 4, 5. So the longest side obviously would be the hypotenuse. 5, 12, 13. That always works out. 3, 4, 5 works out. This one's not very common. You're not expected to know this one. But, I mean, 7, 24, 25. That's a Pythagorean triple because it works out. If you plug in a Pythagorean theorem, it comes out even. Tom has drawn a right triangle with a hypotenuse of 17 centimeters. Alright, I need a picture already. So, right triangle, hypotenuse 17 centimeters, while one leg is 8. Alright, so one leg is 8 centimeters. Jasmine drew a different right triangle. Alright. With legs of 12 centimeters and 9 centimeters. Who has the triangle with the largest perimeter? Alright, so let's think. I have to find out who has the largest perimeter. So to find perimeter, I need to know how big each side is, because perimeter is you add up all the sides. So for me to find perimeter, I need to know how long each side is. So I need to find the missing pieces of my triangles. So let's do them one at a time. I'm going to start here with Tom. A squared plus b squared equals c squared. I'm using the Pythagorean theorem because it's a right triangle. And my hypotenuse is 17. One of the legs is 8. The other leg I don't know. Simplify each side. That gives me 64. 17 squared is 289. Get the y variable by itself, so subtract 64 from each side to make it gone. 289 minus 64 is 225, and that one rings a bell. When I square root each side, y equals 15. So this side here is now 15 centimeters. I have enough information to find the perimeter of Tom's triangle. Tom's triangle has a perimeter of 15 plus 17 plus 8. 30. That's not right. I must have missed a number in there. Clear, clear, clear. 15 plus 17 plus 8. 40 makes more sense. So that's the perimeter of Tom's triangle. So perimeter of Tom is 40. Now, I need to find the perimeter of Jasmine's triangle. So, Pythagorean theorem. A squared plus b squared equals c squared. I'm missing the hypotenuse, so that's going to stay variable. The other sides, 9 squared plus 12 squared. Simplify. 81 plus 144. Simplify. Clear. 81 plus 144. 225. That one rings a bell again. Square root each side, and I'm going to get x equal to 15. So this side here is 15 centimeters. So now I have enough information to find the perimeter of Jasmine's triangle. You'd take 9 plus 12 plus 15 equals her perimeter. 9 plus 12 plus 15 equals 36. So the question was, who has the triangle with the largest perimeter? I had to find the missing side of each triangle in order to find the perimeter. And now that I have the perimeter, I can tell you that Tom's perimeter is larger. Tom has the triangle with the largest perimeter. Perimeter. So that was a depth of knowledge 2. It was not just as simple as, oh, find the missing side. It was find the missing side of the triangle, but then I want you to do a little bit more with it. Letter C. This one's for you to try. A right triangle has a hypotenuse length of 9 kilometers, and one leg has a length of 5 kilometers. How long is the length of the other leg? Go ahead and pause the video, try the problem right now, and when you're ready to continue, hit play. We'll go through it together. Alrighty, so right triangle means Pythagorean theorem. A squared plus b squared equals c squared. It said the hypotenuse was 9. Now, if you need to draw your picture, I actually recommend. 9 is the hypotenuse. One of the legs is 5. 9 is the hypotenuse. Ooh, that's wrong. One of the legs is 5. The other leg, we don't know. How long is the other leg? That's what we need to find out. Simplify each side gives me 25 here, 81 there. Still a squared. Get the variable by itself, so subtract 25, giving us a squared equals 81 minus 25 is 56. Square root each side, and a equals 7.48. So the length of this other side would be 7.48 kilometers. And there we go. We used the Pythagorean theorem. We plugged in the hypotenuse for C, one of the legs for B. We simplified each side. We got the variable by itself. We square rooted each side and found our missing leg is 7.48 kilometers. Letter D, last problem for the day, says rectangle A has a diagonal distance of 10 centimeters and a height of 5 centimeters. Rectangle B has a diagonal distance of 12 centimeters and a base of 3 centimeters. Which rectangle has the largest area? Go ahead and pause the video, try the problem on your own right now. When you're ready to continue, hit play, and we'll go through it together. I hope the first thing you did is to draw yourself some pictures. If you didn't draw pictures and you didn't understand, I think I know why. Draw some pictures. They don't have to be perfect pictures. You're not looking for exact rectangles. Just make it close-ish enough that you understand what you're doing. So here's rectangle A, rectangle B. Rectangle A has a diagonal distance of 10 centimeters and a height of 5 centimeters. Looky, haha, right triangle, hypotenuse, leg, leg, right triangle, yeah. Other side, rectangle B has a diagonal distance of 12 centimeters and a base of 3. Obviously my picture's not to scale, but you get the idea. And again, right triangle, diagonal distance, this side, right angle makes a right triangle, which means both of these problems we can use the Pythagorean theorem. But we're trying to find out which rectangle has the largest area. To find the area of a rectangle, the thing that we want in the end, to find the area of a rectangle is length times width. For both of these, I know one of those pieces. This guy has a width of 5. This one has a width of 3. But both of them, I'm missing the other piece. I need the length and the width. And I don't have it. But using Pythagorean theorem, we can find it for both of them. So let's start with letter A, or rectangle A. A squared plus B squared equals C squared. Hypotenuse is 10. The leg I know is 5. The leg I don't know, I'll leave as A. 25 plus 100 is A squared. Subtract 25 on each side because we're trying to get the A by itself. A squared equals 75. And square root each side. A equals, no clue, clear, 75 square root, 8.66. So the missing side here is 8.66. I now have enough information to find the area of rectangle A. The area of rectangle A would be this 8.66 times by 5 equals 43.3. So the area of A was 5 times by 8.66, which was, what did I say, 43.3. Centimeters? Yeah. Centimeters squared. So that is half of my answer. I know the area of my first rectangle. Second rectangle. I need to use the Pythagorean theorem again because I'm missing either the length or the width, one of those other sides. I have this bottom side, I need the vertical here. A squared plus B squared equals C squared. Hypotenuse is 12, so you plug in 12. The side I know is 3, I plug in 3. The side I don't know is this other thingy here. We'll call it A. So, A. Simplify gives me That's 9 and 144 and a squared. My a's and 9's look kind of alike. There we go. Subtract 9 on both sides. Give me a squared equals 144 minus 9, 135. Square root each side. And a is 11.61. Now that a is not the area. That was the length of this side, 11.61. To find the area of rectangle B is length times width, so 3 times by 11.61, 3 times by 11.61, back, clear, try it again, 3 times 11.61 equals 34.83. So I have the area of rectangle A, the area of rectangle B, centimeters squared. The question was, which rectangle has the largest area? And the answer is rectangle A. Rectangle A has the largest area. The area is larger by about 10 square centimeters. Okay? So recognize that this was a multi-step process. It's looking for the area. So I think, okay, what do I need to do to find area? I need this formula. Well, in both of my rectangles, I knew a part of the formula. I knew, for example, the length was 3 for this one, but I did not know the width. But using the Pythagorean theorem, I could find the width, which allowed me to then plug that in to find the area. That's what is involved in this multi-step process. Summary says, when using the Pythagorean theorem formula, what is the one side of the triangle that must always be in the correct place in the formula? Go ahead, pause the video. This one's pretty easy. Maybe you probably know it off the top of your head already. The answer is the hypotenuse. The hypotenuse has to be placed in the spot for the c in the Pythagorean theorem. A squared plus b squared equals c squared. This guy has to be the hypotenuse. The other two legs, they can be A or B, flip-flopped. It doesn't matter exactly where they go. But this must be the hypotenuse. And there we go. This has been lesson 2.3. Thank you for watching.